Problem 32, balancing chemical equations. So we have 5 chemical equations, and I copied them over here and removed all the states. So maybe it looks a little cleaner. I hope so. When you balance chemical equations, a good strategy is if you see any elements by themselves, like magnesium here and hydrogen there, you balance magnesium and hydrogen atoms last. Okay, are there any other atoms? And you can see there's bromine. So let's give this a shot. So we got 2 bromines on the right, 1 bromine on the left. We want to bring the 1 up to match the larger 2. You always bring the lower up to match the higher. So to get 2 bromines on the left, we cannot do this, of course. That changes the substance. You have to do this, okay? So that fixed bromine. Now we got 2 bromines and 2 bromines. Okay, now we can do the magnesium and the hydrogen. And you see the hydrogens are already done. You got 2 hydrogens on the right. 2 times 1 is 2 hydrogens on the left. And the magnesiums are done as well. So you got 1 magnesium and then 1 magnesium over here. So this one's good. Check. Okay, this is a little simpler here. You got just 3 different substances, and oxygen is by itself, so we'll save oxygen for last. Let's balance the carbons. Okay, so carbon's already balanced. So you got 1 times carbon on the left, so you got 1 on the right, and now the oxygen. So you got 2 oxygens on the right, and then 2 plus 1 is 3 oxygens on the left. Okay, so how do we, you got 3 oxygens on the left, 2 oxygens on the right. Normally you want to bring the lower up to match the higher, but in this case I would probably if you do this, if you put a 2 here, well, what that does is that gives you 4 oxygens on the right, and now you have 3 oxygens on the left. Okay, so if you didn't do that, okay, then you have 2 and 3. Okay, the carbons are fixed. Okay, and so what do? If we try and balance the oxygens by bringing we go over here and 3 over there by putting a 2, that messes up the carbons, and it doesn't even the oxygens. Okay, so sometimes you might be able to just kind of play around with the numbers, and this is one of those that I would probably play around with the numbers. Let's just put that 2 I'm sorry, let's actually do a different approach. So oxygen is by itself. Let me put a 1/2 here. Okay, now we have fixed it. We have 1, and then 1/2 times 2 is 1. So 1 plus 1 is 2 oxygens on the left. Okay, you see, when oxygen's by itself, if everything else is balanced, you can always balance the element that's by itself by adjusting the coefficient on that element. Okay, now this doesn't work because we want whole numbers, but all I do is multiply everybody by 2. So by all the coefficient, 1, 1/2, and 1 by 2, and that's going to give you a 2 here, and then 2 times 1/2, that'll give you a 1 right there, and then 2 times 1 would give you 2 here. So you see, we ended up with 2 on this one over here. You could have just played around with the numbers. So now you got 2 carbons, 2 carbons, 2 times 1 plus 1 times 2 is 4 oxygens on the left, 2 times 2 is 4 oxygens on the right. So rather than doing it all complicated like I did, I might just play around with the numbers, you know. Here you got oxygen by itself again, and let's, you know, see if we need to balance anything else. Okay, looking at the lead, one times you got one lead on the left, one times one lead on the right. So lead is good. Sulfur, you got one sulfur on the left, one sulfur on the right. Sulfur is good. What about the oxygens? You got one here and right there. So you got three oxygens on the right, only two oxygens on the left. So oxygens by itself, we can always fix it. Okay, you got 3 over here and 2 over here. So what coefficient would we put here to change this to 3 oxygens? Well, if you put coefficient of 3 halves, 3 halves times 2 equals 3 oxygens on the left. And this is balanced. And to convert it to whole numbers, again, you multiply everybody by 2. So, and that would change this to a 2, that would change this to a 3, that would change this to a 2, and that to a 2. And so that's what we're going to do. 2, 3, 2, 2 are going to be the coefficients. 2, 3, 2, 2. And everyone is still balanced. You got 2 leads, 2 leads, 2 sulfurs, 2 sulfurs, and then 3 times 2, 6 oxygens, and that's the same as 2 plus 4, 6 oxygens. Okay, to do D, this is a little complicated because you got complicated looking formulas. What I might do here is that recognize that whenever you see sulfur, it comes with 4 oxygens right after that. So rather than balancing sulfur separately, I would probably just balance the SO4s. Okay? Balance the SO4s. So let's see what we have. We have 2 hydrogens on the left, 2 hydrogens on the right. How many SO4s? We got 1 SO4 on the left, 1 SO4 on the right, so the SO4s are balanced. Sodium is not. We got 1 sodium on the left, 2 sodiums on the right. Okay, and let's balance the sodiums. And so to get 2 sodiums over here, we're going to put that coefficient 2 right there. Okay, now if everything is balanced now, 2 hydrogens and 2 hydrogens, you got 2 sodiums, 1 sulfate, that's a SO4. But then you got these other OHs right here. So what you have is 2 hydrogens and then 2 more hydrogens and then 2 oxygens. So that's actually 4 hydrogens plus 2 oxygens. And the way we can fix all of that is by putting a 2 in front of the water. And now everybody's balanced. So you got, 2 hydrogens plus 2 hydrogens is 4. Plus 2 oxygens is 2, and then that 4 hydrogens, 2 oxygens. So that accounts for the hydrogens and oxygens except for those inside sulfate. Okay, so everybody's balanced here. Oh, that was a check 2. And then finally, the last one. Again, I would recognize that every time I see phosphorus, it's connected to 4 oxygens. Okay. So if you want phosphorus, just balance the PO4s. And we got 1 PO4 on the left, 2 PO4s on the right. Okay, you got 3 calciums on the right, 1 calcium on the left. So I'm not sure what I might do here. I might, and then you got these hydrogens here and those hydrogens there, and that's kind of like what we were doing last time. Let's balance the PO4s and the calciums and see where that takes us. So you got 3 calciums over here, 1 over here. So let's bump that up to a 3. Okay. So now we got three calciums. What about the phosphates, the PO4s? You got two phosphates and only one over here. So let's give ourselves two over there. Okay, now we got two phosphates, three calciums, two phosphates. Now we just got to make sure that all of the other hydrogens and oxygens work out. So we got 2 times 3, that's 6 hydrogens, plus another 3, 9 hydrogens on the left, and then 3 oxygens on the right. Okay, so 2 times 3 is 6, and then plus 3 is 9 hydrogens, and then 3 oxygens, okay, over here. And so if we give ourselves 3, you know what, I see that I had this wrong. There's 2 right there. Okay, something was going wrong, so that's what it was. I was having a hard time figuring out what to do next. Okay, so now we got everything else is still balanced, the calciums and the phosphates. So now we got 6 hydrogens, 2 times 3 is 6, and then we have 2 hydrogens here times 3. That's another 6. That's 12 hydrogens total. Okay, so let's put a 6 balance the hydrogens, and that makes the oxygens work out. Okay, so now we 12 hydrogens, and then 2 times 1 is 2, and then times 3 is 6, plus 6 is 12 hydrogens. Then we got 2 oxygens times 3 is 6 oxygens, and yeah, that actually balances everything out. So how about that? Some tricky ones in problem number 32.